of the carbonyls. Amines will add to carbonyls. What we have with amine addition is the nitrogen attacks a carbon on the carbonyl, and then through various protonations and deprotonations, we lose water. When you have a primary amine, that's when there's one alkyl group on an amine, and it adds to a carbonyl, it forms what's called an imine. Basically, what happens is the two hydrogens are chopped off the amine and it's stuck on to the double bond where the oxygen used to be. If it's a secondary amine, which means there are two alkyl groups on the nitrogen, what happens is we have nucleophilic attack with protonation and deprotonation and everything, but because there are two alkyl groups on the nitrogen, it can't form a double bond to it, so it forms a double bond next door, and this is called an enamine. The mechanism for this is protonation of the carbonyl first, because the carbonyl is not attractive enough to a weak nucleophile like an amine, but after protonation it's quite attractive enough for the weak nucleophile, non-bonding pairs of the amine, to add to the carbonyl. That ends up giving us an alcohol group, and through deprotonation of the amine here and protonation of the alcohol, it turns this into an excellent water leaving group, and it leaves. That gives us a protonated imine structure here. That protonated imine then loses a proton, and we get the imine after removal of water. Of course, all this is in equilibrium, and you have to force it to completion by the removal of water. The same thing if we have a secondary amine, you have nucleophilic attack to a protonated carbonyl, proton transfer, water leaves, and once we form what looks like an imine, you can see there's a positive charge here. A proton cannot leave here. So where does a proton leave? It leaves from the alpha carbon, and we end up making the enamine. This nitrogen can't have 4 bonds. It has to have 3 bonds to be an uncharged compound. Here are some examples. This is a primary amine. So what is it going to form? An imine. You chop off the hydrogens, chop off the oxygen, and you basically stick the nitrogen on top of that double bond to form the imine. Here we have a secondary amine. What do? We chop off the hydrogen, and we chop off not only the oxygen but the double bond too, put a single bond there, there's the single bond to the nitrogen, and put a double bond next door. That's an enamine. So you go ahead and try to figure out what are the products of these reactions. This one is a primary amine, so it's going to form an imine. This is a secondary amine, so it forms an enamine. Let's form the imine here. Chop off the hydrogen, chop off the oxygen, and stick them together, and we have this imine. Here we chop off the hydrogen and chop off the double bond and the oxygen, and so we now have, that's what we've added on, and we have to have a double bond from the carbon to the carbon adjacent there. And so we form the enamine. Ylides are compounds which have a positive and a negative charge as a second bond on atoms adjacent to each other. This right here is an ylide. The phosphorus and carbon are singly bound to each other with another bond on top that it is written as a positive and a negative. Sometimes people write it as in a shorter hand as being a double bond there, and that's fine. This is triphenyl phosphine, so these are 3 benzene rings. It has a non-bonding pair and can do nucleophilic attack on an alkyl halide. The halide leaves, and we get this product. Because the non-bonding pair on the phosphorus attacked the carbon to form that single bond there, it now has a positive charge. If we treat it with a strong base like sodium hydride or butyllithium, we remove one of the protons here, and that forms this ylide. It has a lot of negative charge on this carbon, and that lot of negative charge is going to be very attracted to a carbon in a carbonyl. So here an ylide is going to be doing nucleophilic attack on a carbonyl. When it does, it forms this adduct. Notice this is the carbon here, this is the carbon here, and what happens? This carbon comes in and forms this single bond, and that oxygen now has a negative charge, which reaches out and grabs that phosphorus with the positive charge. Remember, phosphorus has empty d orbitals that allows it to make more than just 3 bonds or 4 bonds. It can have more than an octet. So once we form this ringed compound, the electrons move in a cycle, and we form a double bond here between the 2 carbons and a double bond here between the phosphorus and oxygen, and that makes a triphenylphosphine oxide, which is a byproduct, and the compound that we isolate is going to be an alkene. Notice, effectively, what did we do? We chopped off the carbonyl, and we chopped off the phosphine part of the compound and stuck them together on the ends of a double bond. Ylides are formed by an SN2 reaction, and so the alkyl halide needs to be primary or secondary. Best is primary, of course. So if you're trying to choose how to make a particular compound using an ylide, you need to make sure that you put the ylide on the primary carbon if possible. To form an ylide, what do? You take an alkyl halide, like here's ethyl bromide, triphenylphosphine. This is going to do an SN2 on this carbon, and then followed by sodium hydride. It pulls the proton off here, and we end up making this ylide. Here, this is written as a double bond, although theoretically there's a large, huge positive charge here and a large, huge negative charge here that makes this nucleophilic. So when we use it as an ylide, this does nucleophilic attack on the carbonyl, and we end up getting an alkene. Look at the alkene that's formed and where the carbons are. These carbons right here from the ylide are right here. These carbons from the ketone, or the, aldehyde, are right here. So it's like you cut here and you cut there and then stitch them back together again. So you go ahead and determine what is the outcome of this reaction. Well, cut off the carbonyl, cut off the phosphines, and there we go. That's our alkene that's made. What's going to be the product of addition of, oh no, excuse me. I'm teaching this new to you. Okay, here's hydrogen cyanide. The cyanide is nucleophilic and will add to a carbonyl. So there is a negative charge on this carbon, and it does nucleophilic attack on this carbonyl, and the electrons jump up here, and then this proton here adds to the oxygen to give an alcohol. We call this product a cyanohydrin. Cyanohydrin. These cyanohydrins can undergo another reaction, and excuse me. It's not shown here, but we can hydrolyze this cyano group to a carboxylic acid with acid. We heat with a little acid. If I go ahead and I take cyclohexanone and treat it with hydrogen cyanide, I get the cyanohydrin. If I take the cyanohydrin and I treat it with acid, I then form an alpha hydroxy carboxylic acid. This is the alpha carbon to the carbonyl. So we call that alpha hydroxy carboxylic acid. You might have heard them in maybe some like facial products. They're called alpha hydroxy acids, and they're just a little bit more acidic than a regular carboxylic acid. So go ahead and determine what is the product of this reaction. The product of this reaction is this cyanohydrin. So what is the product of that cyanohydrin after hydrolysis? This is the product after hydrolysis. The nitrile basically becomes a carboxylic acid. Notice when we take a carbonyl and we do change it to a cyanohydrin, notice we're adding a carbon. And if we hydrolyze it, look how we change this chain. We changed the chain from a carbonyl, added another carbon on there, and made it into an acid group. Something to remember about